Hey you guys, happy April. It is April 1st, Wednesday, and I'm going to go over your work from Monday/Tuesday and talk about converting, and then we're going to do a SohCahToa review since that's like very, very, very important for pre-cal, but also to remember stuff from geometry. Okay, so let's start with converting. So the first thing is this was your homework. I only got 2 or 3 people, I think, sent me responses, and I gave direct feedback to them. But the concept here is we want to use pi over 180 or 180 over pi. So first of all, number 1 is in radians. So to get out of radians, we want to do this. Okay, so we're going to get rid of pi, and then we're going to take our calculator, and we're going to times 180 times 4. Oops, I forgot my 0. And then we're going to divide by 5, and that should give us 144 degrees. So we have successfully gone from radians to degrees. Those mean the exact same thing. One's just in radians and one's in degrees. Okay? So the next one's in degrees. We want to put it into radians. So we do pi over 180, and then we just put them together like this. Okay? And then you can use your calculator, or if you don't have a calculator handy, you can use your phone. You want to try to find something that goes into both of those numbers. They're even, so you can divide them by 2. So if you want to divide 98 by 2, you know that's what you're doing here. You're going to have 49 pi over 90. If you have the calculator, you can do the ABC button, if you remember that, and that's your final answer. Okay, we're going to do the same thing for number 3. So we're just going to bring the negative over, and then we're going to try to reduce. So I'm going to type it in the calculator and do 62 ABC 180. I do not type the negative, and I do not type the pi. And if you don't have the ABC button, like if you're just using your phone calculator, again, you would just want to try to figure out what can go into both of them. It might take more than one step, but in this case, it's just one step. 2 goes into both of them. All right, number 4, we're going to times by the reciprocal 180 over pi because we're trying to get rid of those pi's. So we have 180 over 12, and then 180 divided by 12 gives us 15 degrees. I forgot my negative in number 3, sorry, and I forgot to box it up, but now it should be good. All right, and then number 5, we want to convert, so we want to get rid of the pi. So we're going to have negative 1,260 over 2, which gives us negative 630. Now, I'm going to pause right here because some of you went like this and added 360 and got negative 270, and then added 360 again, which will give you 90 degrees, and then you circled this. That is incorrect. Now, why would we do this? That would be if you wanted to sketch the graph, okay, and figure out like where your arrows should go. But because I'm simply asking you to just convert, you don't have to do any other steps, okay? So literally, as soon as you get it into degrees, you are done. And that's all you had to do, all right? Okay, so now let's move on to our SohCahToa review, all right? I'm going to do 3 problems with you, and then you're going to do these 4 on your own. Or the last 3, excuse me, not 4. Okay, so let's start by kind of refreshing our memory on what SohCahToa means. So SohCahToa means sine is opposite over hypotenuse. Cosine is the adjacent over the hypotenuse, and tangent is the opposite over adjacent. We also learned something about the reciprocals. Okay, so we learned if you have a S for sine, you need a C for cosecant. and then you just switch the order. Okay? Then if you have a C for cosine, you need an S for secant, and it's just the reciprocal. You flip those. And then if you have a tangent, then you need cotangent, and it's the reciprocal. So it's SohCahToa if you think about the reversed order. Okay? And so now what we're going to do is we're just going to work on reviewing how to do these types of problems, okay? And then I'm going to do 3, you're going to do 3. So the first one I kind of set up for you. I gave you the picture, and I'm asking you to find cosine. Well, let's identify what we need for cosine. For cosine, we need the adjacent over the hypotenuse, okay? So we have the hypotenuse, and we have the opposite, but we do not know the adjacent. So we need to find that. So how do we find the adjacent? Well, we're going to do Pythagorean theorem, okay? So we're going to do 5 squared plus b squared equals 13 squared, okay? And then we're going to type in our calculator. 25 plus b squared, and then 13 squared is 169. And then we're going to subtract our 25. So b squared equals 144. And then take the square root. Is that a perfect square? The answer is yes, thank goodness. Okay, so we just found this side, our adjacent side, to be 12. So now we can fill in our answer. So our answer is the adjacent side is 12, the hypotenuse side is 13, and we're done. Okay? All right, so how is number 2 a little more challenging? Well, first of all, it does not have a picture, so let's draw the picture. Remember, you can put theta wherever you want. I'm a creature of habit. I always put it in the bottom, okay? So sine is opposite over hypotenuse. So I'm going to put my 1 here, and I'm going to put my 16 here. And it wants us to find tangent. So what is tangent? Well, tangent is opposite over adjacent. So do we know those two sides? We know the opposite, but we do not know the adjacent. Okay? So this is my O, this is my H. I need to find my adjacent. So I'm going to do 1 squared plus b squared equals 16 squared. Remember, the hypotenuse always has to go last. Okay? So 16 squared is 250. You know what I meant to do in this problem? Let's reverse real quick. Y'all just switch these numbers for me because, oops, I didn't want that to be so big. I didn't mean for these numbers to be so large. I meant for this to be 4. So let's change these real quick. And then it'll make our math just a little bit simpler. Okay, so now our hypotenuse is 4. That's what I wanted to do. Okay, so now let's go back and do Pythagorean theorem again. So we're going to do 1 squared plus b squared equals 4 squared. So that's 1 plus b squared equals 16. So b squared equals 15. Is that a perfect square? And the answer is no. So we just have to leave it like this and ask ourselves if it can break down. And the nice thing is it cannot. Okay, so we're going to leave root 15 here. All right, so now do we know our opposite and our adjacent? We do. So our opposite is 1, our adjacent is root 15. And now can I leave my answer like that? The answer is no, you cannot leave a radical in the denominator, so we're going to times by itself. The problem child is what I say. And so our final answer should be root 15. Remember, the 1 is understood. You do not have to put it over 15. The shortcut is a root times itself gives you that number, okay, without the radical. All right, if you wanted to put the 1, I wouldn't count it off, but I just think it looks best without it. Okay? And then the last one, number 3. The first thing is, if tangent of theta equals 2. Well, first of all, you have to have a fraction because tangent is O over A. So we're going to make it a fraction by putting a 1 under it. Okay? Now we can say tangent is O over A. And now let's draw our triangle. Okay, so our O is 2, our adjacent is 1. So let's do Pythagorean theorem. This time we do not know the hypotenuse, so it's going to be 2 squared plus 1 squared equals c squared. So 4 plus 1 equals c squared. So 5 equals c squared, and c equals the square root of 5. Okay? So this is our O, our A, and our H. And it wants us to find secant. So what is secant? Well, secant is the reciprocal of cosine. So it's the ha. Okay, so our hypotenuse is root 5 and our adjacent is 1. So can we leave it like this? Well, you can leave a radical in the numerator, yes. You don't really need the 1 in the denominator because any number divided by 1 is that number. So the best answer, final answer for this problem is root 5. Okay? So be careful about Pythagorean theorem that you plug the numbers in correctly, and then just make sure you reference these up top here, so that you remember the order in which those go. And I would like for you to try these 3 and then 4, 5, and 6 and submit them to me through Remind or my email. Either one is great with me. All right, I hope you guys are doing well. Miss seeing you. Bye.